从后面点，字母要从前面点。
从后面吗？对。点个名哦，林凯成、李延轩、刘凯成、赖正佑、罗玉溪、周梦伟、曾彦龙、李雄伟、蔡明启、刘庆峰、黄敏杰、Wilma Wilma Lee I don't know his name. No. And Francis, okay. Ham, Chan, Angelina, okay. 刘冠祥、周玉祥、林宏瑞、林刘德、钟顺怀、王俊祥、Hanley、阿典、Hans No 许彦富、Ovando、Eric、张维成、季荣伟、李书宇、邱宇杰、吴冠贤、林敬环、黄玉坤吗？李子源、黄宇慈、徐家祥、曾泰明、于宇轩、柯之涵、温玉如、林建奇、陈冠全、陈志恩、宋义达、博佑阿古亚娜、郭书月、杨佑安、徐伟霆、李伟成、黄子阳、李维珍、林维珍、赵什么？黄雅欣、王庭锋、陈佑君。Okay, today I will introduction to explore machine learning with crowd source. The first I will talk about what is machine learning. Machine learning is about AI, and AI you can think like generate some function, and this function can calculate your input picture. And the basic, if you know more method, is the rule basic. First, you frame the goal of the product, and you will designer and engineer to develop flow and logic like the right one. If your object height bigger than 10, you do something, and if your object color is blue, you do another thing. And but if you use the machine learning, they will not use logic. Machine learning, like if you frame the goal of the product, and they will training a model using example like this. Your picture is this picture, and your goal is this picture. And if you told machine learning this picture is carrot, they will generate a model, and this model will told you this picture is a carrot. And I will give you a example. This example is about flower, and they have some flower picture like this, and this phone number is the flower picture, like the flower's length or the flower the flower color or something picture. And this target is the flowers. Flower type. Yeah. And if the first type is a 0, and the second type is 1, and the third type is a 2. And we will to supply this data, and I hope you can first to install the model Garden. Yeah, we just type in here. you just get install the Scotland.
把这行指令打到你们的那个终端机，就是我们打到这边来，然后按下 Enter 键，帮我打这行指令，这行就是蓝色框起来这一行，然后打到终端机。因为你们很多人的专题会跟就是做机器学习相关的，所以今天在上课，今天我们就是会跟你说一些机器学习的东西。那安装这个套件就是会做一些，就是等一下要教你做一些，就是像刚刚那个 Iris 就是鸢尾花的辨识，所以你们必须先安装这个套件，等一下才可以做使用。你们有另外一个人直接翘课？被我抓到了。
If you finish, you can try to import. You can try to import the library and try to import the flower data and print that.
要举手。
Everyone, you just install this library, and you can type the spider right. And if you finish, you can load the flower data and print it, and try to print the to our target.
你们电脑要登录你们账号，因为它要 PIP 就是要下载东西，所以电脑要连网络。对，所以如果你们有人没有下载成功，应该是电脑没有连到网络。忘记密码。Jason， 他们电脑可能不能存取，电脑不能安装套件。
他们电脑不能装套件？
对啊，可能存取备具啊。
都不能装，不可能吧？
对啊，存取。
这才可以。
像我装的就存取备具。
但是你用系统开，不能用。
有人也遇到存取备具吗？还是你们都安装完？有遇到。那可以，你们会用 Google Colab 吗？
他们从里面就刷它的，我就直接讲。
没关系，就用 Google Colab， 应该可以装。If you cannot install the package, you can use the Google Colab, and I teach you how to open the Google Colab. You need to log in your Google Drive, and you can find the Connect Raw app, and you type the Colab. Here you type the Colab, and you can find the Collector, and you can open it. You can open it. And now there, you can choose the Google Collector. And you can type the list. You can type list. There.
他们其实是有的，因为我刚才 PIP 它是有东西的。为什么？我刚才 PIP 历史是有东西的，只有 Scala。
那他们电脑都有。
然后他跳是跳的。
就两种方式选一种，一种是你们的电脑可能本身就安装了这个套件，然后所以你打看看， 你打看看这些指令能不能，就是你漏的这个资料之后看能不能跑。那第二个是，如果你不能安装了，你的电脑没有的话，因为你们存取会被拒绝，你就用 Google Colab 去跑，因为 Google Colab 就是免费的 Google 资源，它可以让你安装，可以吗？你们就选一种方法，一个是在云端里面跑，一个是在你这边的电脑跑。
它是有的，只是他不知道为什么不给用，就是他修是修。久违的写一下地方。切分跟测试一样。
我现在找我要讲的切分跟测试。
没有写。
这没有写。
画的。画的。久违写。
那时候给他们先看一下那个影片，然后再简单做一个影片，然后再一起学习。
对。
Everyone finish the practice? Oh. I think someone is tired. Okay, I give you one video. I will control your screen, okay? Okay. I give you one video.
Suppose you have a great business idea, and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data, other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Okay, so the video say that we can split the data to 3 types. Where? If I need later. Oh.
Suppose
There. We can split the data to training, validation, and test. So in code, we split the data to train X, test X, train Y, and test Y. And this function will auto to split the data. And you can try to change this. This like their test size is 0.3, and you can try to change that to 0.5 or 0.7. And the answer will not send in you.
没有，没有。
The answer will different with you run first. You can change the text size in line 40. And you can try to find the text size is bigger or the small is better. The text size means you can see just I teach you 10% seat and I extend another 90%. So if the text size is very bigger, I think the answer will not very good.
This way is about the classification, and you can use a COF dot fit to generate the function, and you can see the chain X and the chain Y, and this is your picture, and the chain Y is your label. So you have this generate function, and you can predict your test. So if you type this and you give this model evaluation score, and they will give you the score. Like this is 0.86. So you can try to type this and try to bring the accuracy. And wait, I will teach you how to use another classification, a classify.
是什么决策树？
And this classifier is the decision tree, and we can call this is about the support vector. And wait, I will teach you how to use the random forest. Is another classifier, and the KNN is a can member. So you can try this and predict the accuracy and the scope.
吗？Finish.
Okay. I introduce another methods. Like okay. Classification is a common application of the machine learning, and the system determines which class or category an example belongs to. Like there is a blue and there is a red. So the output can be a label or percent of the confidence. For this example, if the classifier was trained to identify whether or not an image was of a liars, it may output yes or no. However, if it was more generify an animal classifier, the output could be lion or the tiger. So maybe the blue is the lion and the red is the lion. So the output will yes, this is lion or this is no lion. And another method is regulations. And the regulation system output output will a number. For example, how long it will take to drive from point A to point B, or like how bad someone will hit or on an AD. So regularization, the output will a number, and the classification output will is yes or no. And this tool is the most application of the machine learning. And another methods will like we almost look like it. In prediction, well, we will always use a linear regression or decision tree. Like this sample areas, we use the decision tree. Or another we can use a random forest or neural network. And next week, the teacher will teach you the neural network. So you can try the function. Last year we can turn to random forest.
大家查一下课本，有点忘记。
I search the random forest.
Taste one. T。
Okay, I changed the class for, no, I add the class. So right now, we have the random forest and decision tree, like here, and you can see this. You can you can change some number, and you will let this model go better or not better, and you can try it. And the same, you need to fit your function, and you can predict like this, and use your function to predict you want test data, and the same you will get the accuracy about the random forest, and they will give you a score. And you can try it, and if you finish, you can try to KNN mapper, like we just to search in Google, and they will give you a KNN code. You can try it first. I will search again.
你打 KNN Python 就好。第一个就是。
And don't forget to import the library about the random forest and the support vector, the decision tree.
first is a random forest, decision tree, and a KNN. In different data, we maybe use different methods. And the output answer will be different. You can find. And your project, you can find the best methods you want to use. 好，我用中文说一次，就是我们这边的话，就是建立了3个不同的分类器。那因为你们在 Final Project 有的使用，就是有人会使用到机器学习，那不是说在专案里面3个方式都要用到，你是去选择一个你分类出来最好的方式去做使用。所以你可能发现说，在 Random Forest 里面效果不怎么好，你就可以换一个 Decision Tree 决策树的方式去做。那可能也做不太好，你就可以换 KN 的方式去做。就是你可以上网查很多不同机器学习的方式，也很多不同演算法，那你就选一个用出来最好。Okay. So in final project, you maybe use machine learning, and you can find the first you want. Okay. Because in different data, I think maybe like A data is better than random forest, and B data maybe DKN is good. So you need to choose one who is best in the first, good, better. And you can find in different methods the answer will different. Like in iris data, the random for the decision tree, the answer is better.那一样上传简报，跟上礼拜一样。
跟上面好。
那跟他们讲一下。
We will give you 30 minutes to do your final project, and you need to give our one
对。
Free patch, PowerPoint. Like this, the same with the last page.
剩下的时间是给你们做你们的 final project， 因为6月12号就是要报告。对，6月12号。哦，6月14啊。
You need to presentation, so I think in your final project.
哦，是6月7号吗？
还是可以延后。
哦，是6月7号，那就6月7号。
就下礼拜。延后好，下礼拜。可以延后吗？可以变14号。他刚刚讲可以投资。
If you want to find your group TA, you can let me know, and I will contact with the TA.
And in final project, you need to give me the Word and PowerPoint and the code, your code, okay? And I post in FB in the morning, and you can find what I need in FB group. And there will a demo there, template. You can copy the template and try to write. And today, the next time, I will give them more time to finish it. And today code I will upload to the Google Drive and share with you. And if you have a free time, you can look. And if you want to contact your TA now, you can call me and I will try to find your TA. I will ask her do you have a free time? Okay?
钱给我们当兵买，没钱啊。我真的没钱，你转给我，我打帮你。啊？你转给我，没有，我也上。我真没带钱包了，我帮你。我带钱。你在好不好？没有，我会还的。
来，如果你现在专题很有问题，需要找你们 TA 的，你可以跟我说，我可以问一下 TA 现在有没有空过来帮你们，如果需要的话。那我不保证 TA 现在有空，因为我们有 TA 早上现在其实有课的，他们是有课的。或者说你们可以就是跟 TA 约，就是哪个时间来实验室找他。
还没，我搞一个晚上跑出来，我不会开。
你们想要找 TA？ 你们是不是有他的？
猜啊。
那你们直接问他说想什么，懂吗？你们刚刚说你们现在在做专题，然后觉得我很分享的事情。
我就算打了他一样。
OK。你说这个吗？那个没有唱。
不要录到人了。
Hello everyone. Today I will talk about neural network. In the last week, we teach you how to use the machine learning, and the neural network is very stand about machine learning. So first, we can watch some video.
I never hope to go and do that, but I can go and do this problem, like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it. But for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into the traditional programming just don't work. Instead of going and writing programs to solve a problem, we write programs that learn to solve a problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters.
When you go to the ATM and you give a check and it can read the handwriting,
Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos, here are all my dog photos, here are all my feet photos.
everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. Ooh.
So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn.
But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. we put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud to get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal. It's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that are tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything you can classify as? And suddenly you can go and ask, neural net, what do you think cat looks like? You get a picture of a cat herd. Neural net, what do you think a barbell looks like? These weights. And it goes and shows you a picture not only of a barbell, but an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus. When it's early in learning, the very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing you saw. Whereas, say to a kid, that's a filing cabinet. And then a second later you say, what's that? He's not going to be like, shoe, right?
The more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
Okay. So today we're basically learning a tiny bit of AI, machine learning. But it blocks. Maybe you can make a white screen or turn on. Just want to talk about something, then the TA can show you how to program an AI model in Python. Sorry, I was not here last time. I got my first COVID last week. So anyway, I feel like I'm 99% recovered. Anyway, so traditionally, what a function does for us is that if you have a value x, and if you throw in to a function f of x, then it will give you a number, for example, y. At the end, y equals to f of x. So this is like a machine that gives you numbers if you provide some kind of input. Okay? So usually you get exact numbers. For example, if f of x equals to x squared plus 1. So whatever number you provide to this system, as long as it's a real number, then you end up with another real number, y. There are some other systems like this that doesn't always give you exact numbers. They are like approximation systems. So there are another kinds. They are like approximated. Models. And then they still give you some value y. So what does that mean? I can show you in a graph. Let's say this is x, this is y, and you are doing some experiments, like my graduate students. They sometimes change values of x, and they evaluate a function of y multiple times, and maybe they have a bunch of experimental data. At the end, they build a model. The model could be like this, but as you can see, this model doesn't pass through all the points. It's an approximation. So this is like an approximation of the relationship between y and x. Okay? Why do we do that? Because when students do experiments, even for each point, there could be error. There could be error. So this may not be true. There could have error. Okay, so sometimes you don't 100% believe in it. So you need to do more experiments, and then for convenience, sometimes you just build the model. Okay, so the first kind is the kind of system that gives you precise answer. The second kind of system gives you approximate answer, but usually this works. However, we found out if we want to use this to solve very complex problems using computers, it's almost impossible. What does that mean? If I take a picture of my student, the picture probably, this is a picture of my student, okay? Maybe the size of the picture nowadays, I don't know, the size probably 2,000 times, 1,000 times 2,000, for example. So there are like 2 million pixels, right? Two million pixels. And each pixel represents a color, right? So if I have 2 million pixels, each pixel has a color. It's like I have red, green, and blue, okay? And red, green, and blue, I can use, usually we use values from 0 to 255 to represent the intensity of each color. How red, how bright the color it is, or how dark the color it is. So imagine how many information is there inside just one picture. 2 million pixels times 3 different colors, and all the possible situations ranges from color 0 to color 255. So a lot of information. If I try to program a function like this, and what is x? X are all the possible information inside a picture. I save one picture and then tell the computer, okay, this is my student Jason. So that's, I can try my best to formulate a function that tells me this is Jason, and the information here is a bunch of image data inside. So you can try to formulate a crazy, see how many combinations there? It's like you have millions of x, because every pixel represents a value. You have millions of data. So you can try to build a function y equals to millions of x, a function that forms by millions of x. But you only have one data set, one picture. So I can take millions of pictures of JSON and tell this computer, tell this math, okay, formulate some function. And whenever a picture like this comes in, there should be a result. Okay, this is JSON or not. However, first, building a mathematical model like that is almost impossible. Secondly, if I change my camera and take another picture to my another student, Janice, that earlier model doesn't work at all. I can probably end up with, okay, this picture tells me she is not Jason, but it doesn't recognize Janice. Or if I try to take pictures of every one of you, then I have way too many data. The function could have millions or billions of variables. And you don't even know how the mathematical function should look like. And no computer can handle a mathematical function with billions of variables. It's impossible. So, can we use an approximation tool? Similarly, you can't. Because if you cannot get exact function based on those millions of variables, you cannot have approximating model as well. So in the past, probably 20 years, this problem cannot be solved easily. Neural network come to us several years ago, and then we start to realize, hey, it seems like we can solve this problem by neural network. But neural network is nothing new. It was developed long time ago. The idea was you can have a bunch of inputs, many of them, and you can have, for example, if you are just looking for one output, then you can try to solve some kind of mathematical problem right here. It's like a neuron, okay? And you can solve some others right here. And you can have many of them, okay? You can have something like this. And then until maybe a deeper step right here, you can end up with some conclusion right there. So what do you mean when you have a circle and you have something coming from the left and then something going out to the right? Whatever inside the circle could be a math problem. Could be something like this. Or something like this. It could be anything. Some math. Nowadays, people realize, okay, what you need to do is basically y equals to ax plus b, a linear function. Okay, it's that easy. So whatever you have on the left, you basically build a linear function, and whatever input you throw into this neuron, at the end you end up with a number. So that number will be passing through to another layer, another layer, another layer. So all these neural network has a bunch of neurons, and each neuron has a mathematical equation inside. So instead of solving one mathematical function with billions of variables, they reduce it into small neurons, small circles. And for each circle, it only performs a very simple math and then passing through the output. Okay, so they realize, okay, this method is called neural network. How come this method was developed long time ago but never, it was never well developed at the time. Because we need to figure out, there are some parameters inside. This network could be huge. And there are some parameters, those coefficients. You need to figure out what are the coefficients for each neuron. So this network can perform some kind of estimation. So later on, when I put Jason's picture here from the left, after all the math, it tells me this is Jason. And later on, Janice's picture, throw it in from the left, it tells me, okay, this is Janice. Maybe y equals to a number represent Jason, y equals to another number represent Janice. And I can even build a huge network, y equals to some number representing each person in the classroom. The idea was like that. But they realized this network has to be really huge and also a lot of coefficients to be determined. So what they did was, what was supposed to be done was, you need to solve some kind of optimization to find the optimal coefficients so that the model prediction is precise enough. Okay, so it was a mathematical procedure. At the time when this method was developed, the computer was too slow. So if you use a computer to solve that optimization problem in trying to find the most appropriate coefficients, it takes too much time. So neural network was not popular enough at the time. Nowadays, our computers are getting faster and faster, and we realize we truly can find the optimal coefficient in a very short period of time. So people start to use it to do so-called before AI, there are different names. Something called data mining. So data mining basically is like you have a bunch of data, you are like mining and figure out what's inside the data. And later on, they call it machine learning. And nowadays, they call artificial intelligence. So which one belongs to which one, or are they the same thing, or does AI covers machine learning, or does machine learning covers AI? It depends on how you define it, but for me, they're just names. It doesn't matter. What's interesting is, behind all those terminologies, we have a bunch of math. And those math can help us to make a lot of estimations. So in today's lecture, at the beginning, TAs just show you a video. Inside the video, you already mentioned a little bit about neural network. You saw some pictures of animals or items from the video. You realize they don't directly put this entire picture to neural network. Because even nowadays, a picture like this cannot be easily sent to neural network at this point, because still way too many information. So what happened was, even you have a huge image, they will reduce the size of the image. Okay, so you just don't know. The method actually handles very limited input. So if you take a picture and ask AI to recognize your face, what AI does right now is to reduce the size of the image. Because a picture like this can be easily recognized if you only have thousands of pixels. You don't really need millions of pixels, okay? So in that particular video, I can show you in some of the snapshots. Like you realize over here in the video, it shows some images with really poor quality. How come they are in poor quality? Because they basically show some images that was utilized in their training, and they don't really show, they don't really use millions of pixels. These are like just thousands of pixels. Okay, so I think my point was, AI now is very popular. We are not trying to become mathematician. We're not trying to build an AI model by ourselves. I think as junior students, young students in engineering field, you don't really need to build your own AI model. Okay, but you can get to learn how to use it. So today, my TAs will introduce you how to use them. Okay, and they will be using some really simple examples. Okay, so I will give the time to Jason. He will follow up. Okay, thank you.
我们直接讲20之内讲。
你要讲概念吗？
如果老师讲的都差不多。Okay, I will. We have two small games. It's about neural network and machine learning. So everyone have a PowerPoint. So maybe you can open this URL. 是这个吗？是没有管他们的。没有管他们的。开进去。You just need type this, open this URL. You can find our small game.